let's do some algebraic applications of those two theorems that we just talked about, base angles theorem and converse of the base angles theorem. So let's say we have this triangle. You can see that it's isosceles because the two sides are marked congruent. Now, we need to find the value of x and y. By the base angles theorem, which states that if two sides of a triangle are congruent, then the angles opposite those sides are also congruent, right? So that would mean these two angles here are our base angles, and those two angles are congruent. So we're going to set up an equation, right? And through the power of algebra, let's solve that. So through the magic power of algebra, we get x to be 3.5. Okay, now we need to find the value of y. So to find the value of y, we notice that y is the vertex angle here, right? The vertex angle is the angle that is formed by those two legs. So what we need to do is we need to take 3.5 and substitute it in to find the value of our base angles, these would be 43.5 degrees, and we know that that's 43 degrees in 30 minutes, right? But since we're using this angle measure to help us find the vertex angle, for this point, I'm going to just leave it as a decimal. And then, because we're looking just for the value of x and y, which is not necessarily the angle measure, right? So these two base angles are both 43.5 degrees. Well, that would be able to help me find the value of the vertex angle, because we're going to say 43.5 times 2, and subtract that from 180, which is the triangle sum theorem, we would get 93 degrees. So that means that 11y minus 6 equals 93, and again, through the magic power of algebra, we can solve for y and get our answer, which is 9. Y should equal 9 here. Okay? Let's look at another example. Solving for x and y. Looks a little crazy. We have two isosceles triangles here that share a vertex angle. We have x's and we have y's, and we need to find the value of each. Now you'll notice that two of our x expressions, here and here, are the legs of this, let's say the top isosceles triangle. This x represents, or this expression with x, represents the value of the vertex angle right here. We don't know for example, if you know sides that have x's and angles that have x's, you can't set up an equation involving sides with angles. It's either sides with sides, angles with angles. So what we want to do is just use the two x expressions that are just dealing with the sides. Because it's isosceles, we know that those legs are equal in length. They're congruent to each other, which means that they have the same length. So we're going to set up an equation to solve for x. So we would solve and we get x equals 3. Now, if I want to find y, right? Now y is the next value we're looking for. Y, 15y minus 1 is representing this exterior angle, okay? So we're looking now at this triangle here, this bottom vertex isosceles triangle. Well, we know x is 3, so why don't we substitute x into this expression. So 3 times 30 is 90, plus 13 is 103. Okay, so that means that the vertex angle is 103. Now, if the vertex angle is 103, that means that we could find the value of each base angle. Triangle sum theorem, we subtract from 180. Using the base angles theorem, we know that those base angles are congruent, so each base angle would be 38.5. Okay, 38 degrees, 30 minutes, but again, we're looking for y, so I'm not going to, what is that called? I'm not going to change it over. I don't know what word I'm looking for. I forget the word I'm looking for. Okay, so convert, that's what I'm looking for. Okay, so we know that 38.5 and 15y minus 1 are a linear pair. So we could take 38.5 and subtract that from 180, and we would get that 15y minus 1 has to equal 141.5. And then if we just solve that, we would get y equals 9.5. Yay, we're done.